we're going to talk about permutations, because permutations and combinations, the theme of this lesson, really uses factorials in order to solve them. So a permutation is the selection of a group of objects in which order is important. And if I were to take 5 volunteers and I were to ask, in how many ways can these 5 students line up? We would have 5 ways to line up the first student. Once the first student is selected, we would then have 4 students to choose from for the second spot. Once the second spot is selected, we have 3 students to choose from for the third spot. Once the third spot is selected, we have 2 students to choose from. And then for the last spot, we only have 1 student to choose from. So if we're looking at all the ways a single group of things could be organized, that's a factorial. So 5 factorial, or in other words, 120 different ways we could arrange 5 students. So if we feed off of this a little bit, it says, in how many ways can we line up 3 of the 5 students? Well, there's 120 ways, or 5 factorial ways, to line up 5 students altogether, but we're only selecting 3 of them. But if we're selecting 3, how many are we not selecting? Well, that would be 2. So I'm going to divide this by 2 factorial, because that's the number of students that I'm not selecting. Because when I divide these 2 numbers, it'll leave me with all the ways to arrange the 3 students that we are picking. So you have your total factorial of everyone divided by the factorial of those that you're not picking, and that'll leave you with all the different ways to arrange the students that you are picking. So we get 60. There is, of course, a very formal formula for this, and it is NPR, N standing for the total number of options that you have, and R is determining the number that you're selecting. So 5 permutation 2 means 5 is my total number of things I have, so 5 factorials on top. Then on the bottom, I'm going to take the difference between those two. So 5 minus 2 factorial, because I'm dividing by the number of things that I'm not selecting. So 5 factorial divided by 3 factorial. The way we can do this by hand and not use a calculator, 5 factorial means we're taking 5 times 4 times 3 times 2 times 1. 3 factorial means we're doing 3 times 2 times 1. The really beautiful thing that happens here is 3 times 2 times 1 are common factors in the numerator and denominator, so we can divide those out. Now we're just left with 5 times 4, which is 20. So pretty neat. All right, I want you to work on 8 permutation 6 and 7 permutation 4. So pause the video and press play when you're ready to see the results. All right, so 8 permutation 6 means we are going to have 8 factorial divided by 2 factorial, because that's the difference between 8 and 2. That would mean I'm taking 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, but I'm dividing out the 2 times 1, and that's going to leave me with 20,160. Last one, 7 permutation 4, means I'm taking 7 factorial divided by 3 factorial. So 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1, and I get 840. I am requiring you to show work on these problems. Minimum amount of work is at least setting up the formula, and then you can jump to your final answer. All right, example 4, we're going to apply this to a more applicable situation. So 12 people try out for a baseball team that has 9 distinct positions. And how many ways can the 12 players be selected for those 9 positions? Well, I have a total of 12 people. This is a permutation because the order in which I select the people matters. And there's 9 positions I'm selecting for. So 12 permutation 9. 12 factorial is going to be my numerator. The difference between 12 and 9 is 3, so 3 factorial is my denominator. That leaves me with 79,833,600 different ways that we can select the 9 players Now we're going to talk about combinations, and combinations is exactly like permutations, except order does not matter. So if we think back to like our yogurt parfait problem, let's think back to yogurt parfaits. So in yogurt parfaits, if I have a yogurt parfait and I have peanuts on the bottom, yogurt in the middle, and fruit on top, permutations is where if I rearrange that order and have yogurt on the bottom, peanuts in the middle, and fruit on top is a different permutation. Combinations, though, says, hey, if you have peanuts, yogurt, and fruit, you're going to mix it all up anyways, so the order doesn't make a difference. So combinations, they don't care about the order or the layering of that parfait because you still have the same 3 ingredients, and we don't care how they're arranged. Permutations, though, says, hey, that order does matter, and it does make a difference. So how do we calculate a combination, then, when order does not matter? Well, our numerator is still the same. We look at all the ways to arrange our total number of items, and normally we divide it by the ways to arrange the items we're not selecting. But we're going to actually take that number and multiply it by the ways to arrange the items that we are selecting, because that's going to divide out the fact that we don't care about the ordering of those items we pick. So the formal formula is n combination r equals n factorial divided by r factorial times the difference between n and r factorial. So 5 combination 2, I'm going to have 5 factorial in the top, the ways to arrange everything I pick, divided by 2 factorial, because I'm picking 2 items, times the difference between 5 and 2, which is 3 factorial. So if I do simplifying, I have 5 times 4 times 3 times 2 times 1, divided by 2 times 1 times 3 times 2 times 1. Now, if you're using this method to evaluate these, I cannot cross off all 2 times 1s. I can only cross off one set of common factors. So I'm going to cross out the 3 times 2 times 1s, but I still have the 2 factorial in that denominator. So I end up with an answer of 10. You'll notice that all of your combinations will give you much smaller numbers than your permutations because, again, we don't care about order. 8 combination 6 means I'm going to take 8 factorial divided by 6 factorial times 2 factorial. If you've learned about the factorial button and you're starting to use it and type everything into the calculator at once, I caution you that your denominator needs to be wrapped in parentheses. And this would give you 28. 7 combination 4 is 7 factorial divided by 4 factorial times the difference, which is 3 factorial, to give us an answer of 35. Example 5. There are 12 different colored cubes in a bag. How many ways can you draw a set of 4 cubes? We don't care about the order in which we select the cubes, so this is a combination. So we're going to do 12 factorial divided by 4 factorial times the difference between 12 and 4, which is going to be 8 factorial. And that gives me an answer of 495 ways. So, permutations versus combinations. Always asking yourself the question, does the order matter? So in example 6, the 3 best essays in a contest will receive gold, silver, and bronze stars. There are 10 essays, and how many ways can the prizes be awarded? Well, do we care about the ordering of these prizes? Well, we definitely do. Getting a gold, silver, or a bronze star means something very different. Getting gold versus silver or gold versus bronze is a much different hierarchy, right? You always want to get the gold. So, this one, we are going to have 10 permutation because the order matters. And now we have to think, well, how many are we selecting? Well, we have 3 prizes, so that'd be 3. And we get 720. For the next one, in a talent show, the top 3 performers of 15 will advance to the next round. And how many ways can this be done? They're not saying the top 3 performers are being given first, second, or third place. They're just saying that they're moving on to the next round. So the order in which we select these 3 top performers does not make a difference. So this is a combination. And there's 455 ways to select the top 3 performers. All right, so that wraps up permutations and combinations. If you have any questions, you can talk to myself or Mr. Brasser.